Let's look at this interesting question. Here there is a block. I have drawn this block like this, and there is a wall. Okay, you are looking at the wall itself, and this block is pressed against the wall with the 40 Newton force. This cross means the force is inside the page, right? You are applying the force inside the page, it is going in, and there is a 15 Newton force which is acting parallel to the wall. Okay, let's say it is towards right, it can be at left also, we have taken it as right, and the coefficient of friction between the wall and the block is 0.5. Now the question is whether the block will move or not, and if it moves, which direction it will move, and if no, then we have to find the frictional force exerted by the wall on the block. So let's do that. Let's first ask ourselves the question whether this block will move or not. So here the normal reaction between the block and the wall is 40 Newton. Okay, so if I look it at sideways, you can see, if I look at the block sideways here, the inside force, the pressing force is the 40 Newton, and there will be a normal reaction on the block since the block is not moving in this right direction or any left direction. Then the normal reaction will become 40 Newton. Okay, so this is the 40 Newton force, and from that I can easily get the limiting friction, which is F is equal to mu times R. What is the limiting force coefficient of friction? This is 0.5 into 40. So that will become, I think, 20 Newton. So the frictional force is 20 Newton. Now if the applied force exceeds this frictional force, then the block will move. If it doesn't, then the block will not move. So let's find out that. Now, will the block move? Let's see. Now on this block, if I draw the free body diagram, there is a 40 Newton force inside, 15 Newton towards right, and of course downwards mg force will also be there, right? So the mass of the block is given to be 2 kg. I'm sorry I didn't tell you this information before. So mass of the block is 2 kg, which is given. Let's find out the net force. So the net force will be 15 Newton and mg, both are at 90 degree. So resultant net force because of these two forces will be square root of 15 square plus mg. So what will be the mg force? Mg will be 2 into 10, that is 20 Newton. So this will be 20 square. So here I can write it as, can I write it 5 square into 3 square plus 5 square into 4 square. I have just factorized this in 5 into 3, 5 into 4. Now I can take 5 outside. It will become 3 square plus 4 square. So 5 times 9 plus 16 is 25. So this will become 5 into 5, 25 Newton. So the net force is 25 Newton. Then of course this is greater than the frictional force, and hence it will indeed move. Now what is the direction of its motion? In which direction it will move? So it will be moving somewhat like this, 25 Newton force. Okay, but what about this angle? We have to find out the direction, because they have asked if it moves, find the direction in which it is moving. So let me write this angle as theta here. Now you can see from here 25 cos theta is 15. So I can write here as 25 cos theta is equal to 15 Newton. So cos theta is equal to 15 divided by 25, which is 5 3s are 15, 5 5s are 25. So cos theta is 3 by 5. Then that means what is the angle theta? So we know that famous triangle, that theta is, this is 5, this is 3, this is 4. Sorry, here I will take it as 3. Is the adjacent side, right? 3. This is 4. Now if such a situation occurs, this is 53 degree. The angle which is opposite to the side 3 is 37. So this will become 53 degree. So theta must be 53 degree. So now the resultant force is 25 Newton. Okay, and which is greater than the frictional force. This is the resultant force of these two forces, right? 15 and mg. I'm not saying this is the force which is applied, because of course there is a friction as well, right? So friction will be in the direction opposite to this. This is the resultant of this 15 Newton and mg, not the resultant force overall. Okay, so there will be a friction as well. So now this is the force in this direction, and the friction will be opposite to that of that. Okay, in this direction, and that angle theta just now we calculate is 53 degree.